So in this part, the lecture will study some command logic operators, or how do we manipulate the bits, or how do we manipulate the proposition statements with only two values, which is true and false, in order to create new knowledge. So last time we already studied that propositional logic deals with setup propositions or similar to setup bits because they can be true or false, and the relationships among them in order to manipulate this bit in order to create the new knowledge. So now we'll study about all the kind of relationships that we have learned so far, and they are called as the logical operators. Okay? So logical operators act on propositions to get new compound proposition or create new knowledge. Now, then the next concept over here is called truth table. So the truth table is actually taken from all the related input propositions, like input proposition 1, input proposition 2, up to input proposition n. And on those, they're going to find, for those, okay, what is the output propositions. Okay, so it's gonna list, this one is, let's say, for each of the proposition, you either have true or false, and you have a combination with all the other propositions. Then they come to list out what is the output of this compound, okay, propositions described by this relationships that we have over here based on the combination of all the input proposition. What is the output? Okay, so this one is called the truth table. Again, it lists the truth values for the compound propositions, which is this one. Okay, for all the combinations are all the input components, which is proposition 1, proposition 2, and proposition n. So this is a summary, if you prefer, in text of what we have seen so far. Now we're going to move on the first logical operators, or first kind of manipulation, or first kind of relationship, which is the negation operator or the not operator, and its notation is gonna be denoted as this one. So what is this one is a not operation operates on one proposition P is called not P, and it is defined as false if P is true and it's true otherwise. So it's just negate the values. And that's why we're gonna have the truth table for it in here. We have P and corresponding not P. If P is true, then it's false. If P is false, then it is true. And this one is one operations that help us to manipulate the bits. Okay? Why do we have to manipulate the bits? Again, we need to start from one bit and produce some new knowledge, produce some new information. Now, examples, this one is, let's say we have a bit that is store true proposition, which is 2 plus 2 equal to 4, and we want something which is not the same as that one. Then we'll get not P, which is a false proposition. Then let's say Q is 2 plus 3 equal to 4 is a false proposition, and if we negate it, we're going to get a true proposition. Now this is the summary of what we have said just now, and we should note that there are some other kind of notations for the negative P, which is a bar. This bar doesn't seem to be displayed well, but there is a bar over here that shows that is negative P as well. Now the next command operators in order to produce new knowledge from existing two bits is the AND operators. And this AND operators, it works on two propositions, or it's going to work on 2 bits, and it is called P and Q, and its notation is like this, which is a hat. Then this one is defined that it is true if both P and Q are true. So it's going to produce a new bit of on if both of its input bits is on. Okay, otherwise it's going to produce off. So so the truth table for it is going to be represented this way. So you will have P and Q, and then you will have P and Q over here. And I highlight, if you feel like the definition is long, I highlight the part that we need to memorize in order to produce all the other output as well, which is it's true only if both P and Q are true. And all the rest for the combination of P and Q, you'll have false for them all. Okay, so this one is the AND operators. The example of this one is, let's say I'm going to have P is 2 plus 2 equal to 4, which is a true proposition. So the next one is Q is 2 plus 3 equal to 4, which is a false proposition. Then if we say P and Q, okay, not just one, but both of them, we want to state that both of them, then it's leading to a false proposition. Okay. And this is the summary of conjunction or the AND operators that we learned just now. Another one very commonly used proposition operator is a logic operator, which is the or disjunction operators. Then this one is defined and works on two bits or two propositions with P and Q. So it is written as this notation, and it is read as P or Q. And it is defined as it is false if both P and Q are false. Okay, both Q and P are false, otherwise it's going to be true. So from there we can have our truth table defined as PQ and P or Q. Then again, in order to not having to memorize everything, it's easier to just memorize the phrase over here, false if both false. So it's this line for us to memorize. It's only false if both false. Otherwise, everything gonna be true. And the examples of this gonna be P is 2 plus 2 equal to 4, which is a true proposition. Then Q is 2 plus 3 equal to 4, and this is a false proposition. And we say it's just P or Q is true. Just P or Q is true. Okay, and then this one is a true proposition because one of them is true and that one is P. So here is a summary of the disjunction operators that you can read. Okay, and a note over here is some of the time people are gonna write them as P plus Q, and this one in logical operation is acceptable as well. Now the next common operator to produce no new knowledge from bits is the exclusive OR. So it's not the OR but exclusive OR operation, and it's gonna be written or denoted as this. And it is going to be read as P exclusive OR with Q, or this one is P and exclusive OR with Q. And it is defined as it is true if P and Q are different. You cannot have both. It's just exclusively, you know, P or Q exclusively. You can have both of them be the same. So the truth table gonna be P, Q, and again the highlighted part is it's only true if P and Q are different. Okay, it's only true if P and Q are different. Let's give an example over here is if P is 2 plus 2 equal to 4, it's a true proposition. Then Q is 2 plus 3 equal to 4, which is a false proposition. Then we'll say P exclusive OR with Q is a true proposition because it is this line. Okay, because it's this line. Now this is summaries of what we have seen just now, if you prefer to see them in text. Now, the next commonly used operation is the conditioner if, then, or its notation is gonna be like this. So it is normally read as P implies Q, or written as P and this notation then Q. It is defined as it is false only P is true and Q is false. Okay, it is false only P is true and Q is false, which means that if you have the premise, which is P, then you have to have the consequence, or the conclusion have to be true. If you have the premise is true and the conclusion is false, then that is not correct. Okay, so this one is the truth table again. Everywhere else is going to be true except if you have the premise is true, but you have the consequence is false, then that one is not true. Okay, so but if you have the false premise, and whatever comes with the consequence is fine, is true. Okay. So this one, let's just have some examples as well. If P is 2 plus 2 equal to 4, it is a true proposition. Q is a false proposition. Then P implies Q is a false proposition because it's this line. Okay, P is true and Q is false, then it's going to produce false. And this is the summary of conditioner if then. Okay. But we have seen this now, if you prefer to read them in text. The next important logical operators is biconditioner, and it is denoted as this. P if and only if Q is equal to this P and this notation on Q, and it is defined that it is true when P and Q are the same. They have to be the same. Okay, so it's false otherwise, and it is false otherwise. So that's why this is the truth table for it. Okay, if only P and Q are the same, then it is true. It's only P and Q is the same, it's true. Sorry, this one have to be this notation. I just forget to replace it. This one have to be that notation. Okay. The examples will be P is 2 plus 2 equal to 4, then it's a true proposition. Then Q is 2 plus 3 is a false proposition. Then P if and only if Q is false proposition, because they're not the same. So this is the summaries of the biconditioner if and only if. Then the order of operations, we will start with the not first. Then we'll have the and operation, then you'll have the or operation, then you have the conditioner statement, then you're gonna have the biconditioner statement operations. But whenever in doubt, it's just simple to use parentheses, okay, with high case order or operation. Okay, so this one is again the summary of what we should learn from previous slides if we use text form. And in the next part, we'll learn some other related terminology.